Hello everyone, I'm Umashankar. I'm here today to showcase the demo of one of my recent projects that is built using Spring Boot and microservices. It is AI-powered fitness application. So my intent to build this project is that with the AI boom happening all around us, every enterprise application wants to have some sort of AI integration in the systems, be it as an AI chatbot or as an AI recommendation service like this one. So I wanted to learn how we can integrate AI into the existing microservice architecture or integrate it while building an entirely new system. Here we have the system diagram of our application. We have the clients here that are trying to access using the REST API. We have three microservices here, that is a user service, activity service, and AI service, that are protected and can only be accessed through the API gateway over here. The API gateway is doing the job of routing the request to the appropriate microservice based on the request it receives. Security is an important aspect in any application. I have made use of Keycloak over here to protect our REST APIs. I have implemented the OAuth2 authentication system where we'll be making use of JWT tokens and will issue these JWT tokens to the clients, and the clients can present these JWT tokens as a ticket. The Keycloak also works as an identity provider for our application. It manages all the users and user identity. So what happens is the clients, they using the front-end application, they try to access the microservices. They reach the API gateway over here. The API gateway will try to authenticate themselves using the Keycloak, or it will verify the username, password, and credentials, and then it will give them a token. In the subsequent requests, the clients will share the token, and if it is valid, it will be given a pass to access the microservices. Not will encounter the 401 unauthorized. Now coming to the core microservices, we have a user service, activity service, and AI service. The user service, it is responsible for keeping all the user profile information, and it is an extended version of the Keycloak that we have. Because in Keycloak, we can only store username, email, and passwords. We cannot store additional, information that are useful to generate recommendations, like the user's dietary preferences, his height, weight, etc. All those information will be stored in the user service. Then we have an activity service. Here we'll be storing all the type of activities that the user has done. For example, running, swimming, walking, etc. How many calories he has burnt and how much duration he has done that particular activity. Then we have a AI service. This is responsible for generating AI recommendations based on the data it is receiving from the activity service. We are making use of Postgres relational database for the user service, and MongoDB for activity service, and a MongoDB for AI service. And this is the beauty of microservices, I would say. For each service, we can have independent databases set up, and each service can work independently. So in high-level backend scaling system, separate teams can work on separate services independently and scale them as they want. We are making use of two types of communication here. One is synchronous communication that is happening between activity service and the user service. So whenever a new activity is being recorded in the activity service, it first queries for the user service and asks if a particular user for this activity exists or not. If there is no such user that is claimed by the activity request, then the activity service will just return that this is an invalid user. Only if the such particular user exists in the user service records, then the activity service will generate and store the activity of that particular user. So this is synchronous communication. This happens as soon as the activity service gets a request for an activity. Whereas we are making use of asynchronous communication between an activity service and an AI service. For this, we are making use of RabbitMQ and its queue over here. So what happens is, as soon as the activity is published in the activity service, it is pushed into the queue of the RabbitMQ server, and the AI service will be listening to this queue. Whenever there is an activity pushed into the queue, it will take that activity and generate the AI recommendations using the Google Gemini API. So the important use case of this asynchronous communication is that, let's say out of these three microservices, the AI services is down. So if we had used an synchronous communication over there, that would make the entire system stop and not receive any further more requests because the system is down. But with the help of this asynchronous communication, even if AI service is down, the activity service can continue, receiving more activities and keep pushing them into the RabbitMQ queue. And whenever the AI service is up and running, it can go to that queue and start generating recommendations for all the pending activities that are present in the queue. So this removes the system from having a single point of failure. Even if one or more services are down, the system still keeps on running. Apart from the three core microservices, we are making use of RabbitMQ, as I mentioned, for asynchronous communication. We have a configuration server. So the configuration server is useful for large-scale backend systems because instead of having local configuration for every microservice, it's better to have one configuration server using which we can configure and keep track of the configurations of all the services at one place. So in future, if we need to make any type of configuration changes, we can simply handle it using the configuration server instead of going and doing the changes locally in every single microservice configuration file. And then we are making use of Eureka server for the inter-service communication, and it helps in service discovery. So this is how the entire system and all the microservices are interconnected and work together as a single functioning application. Another thing I want to highlight is with using the same architecture, we can build multiple projects. For example, if you're into finance, we can build a loan eligibility platform where we check the status of loan using AI. That would be a much faster method than the manual process. We can build multiple projects using the same architecture. Before proceeding to the demo of the project, I wanted to show all the port mappings that we have done in the project, because let's say if you are using my project, since there are multiple services running in different ports, it can get confusing. So I just wanted to brief about all the ports we'll be using. We have 8081 for user service, 8082 for activity service, 8083 port for AI service, 8084 for the API gateway that will go to all the services, and the configuration server is in port 8888. The Eureka server is in 8761, Keycloak is in 8181, the RabbitMQ server is in 5672, RabbitMQ user interface using which we'll analyze all the queue data, it is in 15672, and the React frontend app, it is running in port 5173. Now let us proceed to the demo of the project. Let us wire up the backend first. Here is my IntelliJ IDE. So as you can see here, we have all the services here: activity service, AI service, configuration server, Eureka, fitness app frontend, and the gateway application, API gateway, and the user service as well. You can notice that for all the services, we have this rectangular blue box over here. That means it is a Maven build project. Only for the front end, we do not have it as it is a React. First, let me start up the configuration server, because all the services will come and receive the configurations while booting up through the configuration server itself. With the configuration server up and running, let me start the Eureka server, because this is where all the services will come into the client discovery and proceed with the inter-service communication. With both of these up and running, let us go and start the user service microservice and the activity service. Now I'm starting the AI service and also the gateway application. So you can have a look at the logs of the configuration server here. All the microservices like the user service, activity service, AI service, and the API gateway, they are coming to the configuration server to fetch the configuration files. And from here, they are getting the configurations while started. So this creates a centralized configuration system. And even in the Eureka server, if you go to the logs here, that every microservice, they're coming and registering themselves here in the Eureka server for service client discovery. Through here, they will do the inter-service communication. We can also go to the port of this Eureka server, that is 8761. I am at localhost 8761, and this is the Eureka server. And here you can check that activity service, AI service, API gateway, user service, all of this has came and registered themselves to the Eureka server for inter-service communication. Now let us start the Keycloak and RabbitMQ servers. For these services, instead of installing them manually, I'm using Docker containers. I have pulled the official images and run them in the Docker desktop. So it makes it easier, to set up and manage these services instead of manually installing both of these applications in my system. Alternatively, you can install them directly in your system, but this type of containerization, it provides me better isolation and portability to use the services. We can have a look here. The Keycloak container is running in my system port 8181, and it is mapped to the port 8080 of the official image. And here RabbitMQ interface is running in 15672 and the server is running in 15672. Now that all the services and servers are up and running, let's start the databases so that we can monitor the information being transferred to the database directly. Both the databases are up and running. I have navigated to the port of 5173 where my front end is. Let us start logging in to the application. First, let me try putting in a random user who does not exist in our database and see what response it will give us. Blue is the username, and the password is the random password. You can see that when I put a random user who does not exist in the system, it is saying it is an invalid user or password. Now let me navigate to the Keycloak administration panel, that is in port 8181. Here I need to log in with my admin settings. Here you can see that I have created a realm for a fitness application, and in the users part you can see there are only two users. So if we use only these two users, only then the front-end application will authenticate them and they will be able to access the application. Let us add a new user here. Email cute coder. Here I have turned off the temporary button. So if this was turned on, after once you log in, every time you need to change your password. So since we are doing it for testing purposes, I have turned it off. Now the new user cute coder is created. Now let us try logging in our fitness application. So here is the front end. Cute coder. So you can see that we have successfully logged in to our application using the OAuth authentication system. Now let us go to the backend and have a look at the logs of API gateway and the user service microservice. Here in the API gateway, you can see that validation API has been called for this particular user ID, and the email of that user ID is cutecoder@email.com. This is the same exact user that we just now created. And if we go to the user service microservice, here you can check that user validation API has been called. If we go to the Postgres and see a new user called a cutecoder has been registered in the database. Let us go back to our application. Now let us try registering an activity. You can see right now there are no activities here. But before doing that, let's go to the MongoDB. Here I have created a lot of activities to test this application before. Let us delete all these activities. Now you can see that all previously existing activities, I have deleted them. Here is my database that is fitness activity and the collection is activity. Now let us create an activity here. I'll say, swimming. I did it for 40 minutes and the calories burned is, let's say, 600. So the activity has been added. Now let us go to the RabbitMQ management port and see if this activity was pushed into the queue or not. It is in port 15672. Let me quickly log in. So here you can see the overview and let me go to the connection. This is a currently established connection and you can check over here. This is the activity that we just pushed and it has already been picked up by the AI servers and this is it. If we go to the exchanges, you can see that we have something called as fitness.exchange. This is the exchange using which the AI service is picking it up. If we go to the queues, we have a activity.queue. This is the queue to which the AI service is listening to. So now let us go to the backend and check the logs of our activity service and AI service. Here is our activity service logs, and you can see that for the same user ID that we created right now, an activity has been published and it created a connection to the RabbitMQ and it pushed the activity into its queue. Or you can check also the port here. The port RabbitMQ is running is 5672. And now let us go and have a look at the database in the MongoDB. So earlier it was empty. Now let's refresh it. I had deleted all the documents present in this MongoDB activities collection. We can see now that the activity that we just published, that is swimming for 40 minutes and the challenge is 2600. It has been recorded in our MongoDB database. Now let us go to the front end and check the AI recommendation that we have received. Here is the activity and this is the AI recommendation we have received. Overall pace, what calories, heart rate, what improvements can be done, and the suggested workouts, safety guidelines, everything. Let's go to the backend and check the logs of this AI service. So you can have a look here. We have received an activity for processing and this is the activity ID. So we can have a look at the response from AI here as well. This is a 40-minute swimming session. We have spent around 15 calories per minute, which makes it 600 calories for 40 minutes and everything. Now we can go and have a look at the database of this recommendations to see if it has been updated in the AI services database or not. This is the fitness recommendation database, and inside that we have a collection called recommendations. So these are all the previous recommendations that I have generated. The current one, swimming, is over here. You can have a look at the improvements, suggestions, safety, everything. It has been recorded in the database. If you go and have a look at the logs of our API gateway, you can see that every single request that we have processed right now has went through the API gateway itself. And this is the user ID of the particular user we just created. So another test case, what we can do is I can turn down the AI microservice and the system will still continue to function. The activity that I register, it will be pushed into the RabbitMQ queue. And whenever the AI service is back online, it will listen to that queue and take that activity and then generate recommendations. Let's test that as well. I am stopping the AI service over here. You can check here that the process finished with exit code 130 and the AI service is down right now. I'll register the activity now. Activities, add an activity. So let's add a cardio. We did it for 120 minutes and the calories burned is, let's say, 500. So the cardio activity, it has been registered, but the recommendation is not ready because the AI service is not up. So we can go and check the logs of the activity service. The activity has been registered. We can also check the user service logs. Here, the activity service has queried for the user service to check if the user exists or not. And we can say that the user exists, so it has allowed the activity service to create an activity. And if you go to the database of the activity services, here in the activities, a new document called cardio, it has been received. But the AI recommendation is not ready because we have turned off the AI service. So now if you go to the RabbitMQ management portal and check in the queue, we have one ready activity, but it has not been received by the AI service yet. And so whenever the AI service is up and running, it will receive this activity and then work on it. So now let us start the AI service back. So see, as soon as I turned on the AI service, it received the activity that was in the queue for the processing, and it has started processing it. So the AI microservice has finally generated the recommendation for this new activity. We can have a look at it here. Analysis, improvements, suggested workouts, safety guidelines, everything it has provided us. If we go and have a look at the logs, you can see the response from AI here. Everything, analysis, area, suggestions, safety, etc. If we now go and have a look at the MongoDB database, we should be having a new recommendation after, swimming. So here it is, cardio. So this demonstrates that even if one or more microservices are down or have failed, even then the system will continue to function and will keep receiving activities that are being sent by the user. And whenever the failed systems are up and running again, they will pick them up and they'll work and generate the recommendations. This removes the single point of failure in our microservice architecture. This shows how different microservices collaborate to deliver a complete feature. To summarize, this project demonstrates microservice architecture, service discovery using Eureka, centralized configuration using config server, asynchronous communication using RabbitMQ, and AI integration using Gemini, and secure authentication using OAuth2 with Keycloak. If you get any doubts or issues while setting up this application in your own server, I have also created a blog post where I have written a complete blog on how to set this up and how to set up all the servers, ports, everything up and running. You can check out my blog post as well. Thank you for watching.